Mid-segments video, part 2. So now we're ready to answer parts E and F on your worksheet of proving the triangle mid-segment. Okay. So far on this worksheet, we proved that the mid-segment and the third side are parallel because we found that their slopes are the same. So now we're going to want to prove that the length of side AC, or I'm sorry, of side MN is half the length of side AC, okay? And in order to do that, we're going to need to use the distance formula, okay? So you may or may not remember this formula from grade school, but if you ever want to find the distance between 2 points, you use the distance formula, which is the square root of x1 plus x2 squared. I'm sorry, not plus, minus. Ooh, losing my mind. Minus, there we go, plus y1 minus y2 squared. Okay, so we're going to use this formula. So for part E, to find the length of AC and the length of MN, that's what it's asking for there when it doesn't put the lines over it. We're going to just go ahead and plug the coordinates into the distance formula. Okay, so AC will be pretty straightforward looking. Okay, it'll be the square root of, and then my x1 and x2, that'll be my A and C. So A minus C squared plus, and then my difference in my y, so h minus L squared. Okay, and then there we go. That's the distance of AC. For length of MN, sorry about that, you're going to have the square root of, all right, and give yourself some more room here, x1 minus x2. So that's going to be a plus b over 2 minus b plus c over 2 squared plus, and then my difference in my y's, so that's going to be k plus h over 2 minus k plus l over 2 squared. Just like that. Okay, so there you go. There's your length of AC and your length of MN. Okay, notice for part F, they want us to simplify our responses to part E and show how they demonstrate that the length of MN is half that of AC. Okay, so if you look at this, you can see AC is pretty much as simple as it's going to get. Okay, but MN, we can do a lot of work to this. Okay, so for example, we can go ahead and start subtracting these fractions because they're both over 2. So don't forget that minusing is going to happen to both of these on top. So this would end up being A plus B minus C, all of that over 2 squared, plus, continuing on here, we're going to have K plus H minus K minus L, because remember that minusing is happening to both of those, all over 2 squared. Okay, and then notice I have a B and a minus B. Go ahead and cross those out. I have a K and a minus K. Go ahead and cross those out. So that means that at this point, I can go ahead and write it as A minus C over 2 squared plus H minus L over 2 squared. Okay. All right, we're doing good, okay? So the next thing we're going to use, because remember, I'm trying to get to the point where I can show that this is half the length of AC, so I'm hoping to eventually take some halves out of this. That would be fantastic. So what I'm going to do is I know that when I square a fraction, I can actually square the top and the bottom separately, okay? So if I do that, this is going to end up looking like A minus C squared on top, but then I can go ahead and square 2. 2 squared is 4, okay? And then I can do the same thing with the other one. So this will be H minus L squared over 4. Okay. Now notice, another nice thing, they're both over 4, right? Okay, so let's go ahead and write that. So we can say now that we have across the top here A minus C squared plus H minus L squared all over 4. And when I have square roots, I can do exactly the same thing that I was talking about there with the squareds, okay? I can take the square root of the top and the square root of the bottom separately, okay? So that would leave me with A minus C squared plus H minus L squared on top, all over the square root of 4, which the square root of 4 is 2. And here is the grand reveal, okay? Because notice the distance of, why is this not selecting? Sorry, my computer is, there it is. All right, so notice the distance of AC and this right here. Okay, they're exactly the same, right? So the only difference between the distance of MN and the distance of AC is that the distance of MN is divided by 2. Okay, and that's exactly what we were just looking to show. Okay, so this shows that the lengths of MN is divided by 2, or half of AC. And that is our proof. Fantastic. Okay, so that was pretty cool. That's how we prove that these figures are, hold on, computer's messing up again. All right, so that's how we prove the triangle mid-segment theorem. Okay, so keep that in your notes. And be sure to reference back to this, okay? All right, so now I've just got a couple questions for you. So first of all, are the mid-segments of an isosceles triangle congruent? And to that we would say, think about it for a second. Yeah, no, not really. But what about the mid-segments of an equilateral triangle? I think you would agree that those would end up being congruent. Draw yourself some pictures if you'd like to explain, okay? Here's another question, all right? So I'm given that DE is parallel to AC, so I'm thinking, all right, so that satisfies the triangle mid-segment theorem. So I'm asking myself, is DE a mid-segment then for this triangle? But when I look at this, there's an issue, right? Because look at this. Remember, the definition of a mid-segment's got to be connecting the midpoints. So does this show that this is a midpoint? It does not. Okay, so this is a big no, because E and D are not midpoints. So it won't be satisfying that definition of a mid-segment. Okay, so even though it has the property, it doesn't satisfy the definition of a mid-segment. Okay, here's another good question. Okay, so we've got XY is a midsegment of triangle DEF. We want to find each measure. Okay, so the first one is XY. Well, that one's pretty simple, right? This is EF, it's 17, so half that would have to be XY. So 17 divided by 2 is going to be 8.5. Okay, now here's an interesting question. What would be DX? Okay, think about it. All right, remember that X is a midpoint of this side, if this is a mid-segment. So if this part is 6, that part would also have to be 6. I know it doesn't look like it, but it is. Okay? And then, so same thing down here. If this part's 4, this part would also have to be 4. So remember, it's a midpoint, divides those sides in half. Okay? All right, and last but not least, so QR is a midsegment of triangle WYZ. We want to find the measures, okay? And the first thing they ask us is, what is X? So we're going to have to set up an equation, right? Okay. Now, I could think to set these equal to each other, but then I remember they aren't the same length, okay? However, I do know that this is half the length of this one, okay? But for the purposes of my equation, I'm going to use actually the fact that this is going to be twice the length of this, okay? Because I would prefer to multiply an equation by 2 than to divide it by 2. So I'm going to write this right here as 2 times 2x minus 2.5. Set that equal to 2x plus 7, and then I can solve. So that would be 4x minus 5 equals 2x plus 7. Let's take care of these x's first. So this will be 2x minus 5 equals 7. Add 5 to both sides. Get in 12. So that leaves us with x equals 6. And then from there, we can definitely find out WZ, okay? So WZ, plug in 6 for x. So 2 times 6 is 12, plus 7 is going to be 19. And then plug in 6 here. 2 times 6 is going to be 12, minus 2.5, so that's going to be 9.5. And yep, you can see that QR is going to be half the length of WZ. Perfect. Okay. All right, so at this point, go ahead and obtain the homework. It is the mid-segments worksheet, and we will talk about that on Monday when I see you. Have a fantastic weekend.